Hi, welcome to part 2 of vector equation of a line. So in the last part we saw how to write the equation of a line in vector form. So here we have a line in 3 dimensions and we want to write the vector equation of this line in parametric form. And so to do that, again, my rule is going to be very simple. It's just following along. So if I look at my x's, x equals my x component for my initial starting point. Remember, this is our initial start. This is my direction vector. So to write this one, I start with the 2, and this time be careful, there's a minus. I can put a plus there if I want to. I'm crazy that way. Plus, ready? If I distribute the t to the first one, that becomes plus 1t. So I can go 1t. And if I do the same thing for the y's, I'm starting at negative 1 plus, and if I distribute the t here, this becomes plus 2t. And I can do the same thing for the z's. I can say z equals, this is 3, and if I distribute that minus t, now I get minus t. And that would be the vector equation, the parametric form of our line in 3 dimensions. Again, we sometimes parametrics are nice because here we can only look at how z is being affected. Here, how y is being affected. Here, only how x is being affected. Parametric form has a lot of really good applications for us in physics because we can look at each individual component independently from each other. In the vector equation of the line, if I want to find out what's happening to x, I have to understand what's happening to y and z. But in parametric form, we don't necessarily need for that to happen. And now comes the fun part, how to convert these into rectangular form. Once a vector is in parametric form, we can convert to rectangular, or sometimes you're going to hear us use the phrase symmetric form. And we do this by solving for t. So if we want to convert the question number 2 in parametric form, that was from earlier. So question number 2 was the following: x equals 2 minus 5t, y equals 3 plus 2t. This is just going from a parametric to rectangular, and you might remember this from Algebra 2 and Pre-Cal, where you just solve for t in one, right? So if I solve for t in the first equation, we're going to get x minus 2 divided by negative 5. Now, there are 2 ways I can do this. One, I can plug this t into my second equation, and I can get my equation right there. Now, that's pretty easy to do in 2 dimensions. In 2 dimensions, I can just substitute in. I can substitute my t in for my t for y, and I would get my equation of my line. In 2 dimensions, that's super easy. But in 3 dimensions or more, not so much. So we call this symmetric form because we're going to be looking more for like symmetry and things like that. So what I can do here is, instead of plugging it in, I can solve for t in my second equation as well. And if I solve for t here, we get y minus 3 over 2. And so much easier now. It's, well, this is t and this is t. Well, by our law of our transitive property from geometry, we know that these two have to be equal to each other. Therefore, I can say x minus 2 over negative 5 equals y minus 3 over 2. And I can leave it like this. I mean, you could solve for y, which would be easy in 2 dimensions, like we have here. I can solve for y easily here, but in 3 dimensions, it's not so much. So we can leave it like this. This is called symmetric form. So let's try one in 3D. This will show you how much more complicated it is. So we're given the following points where I'm starting, 1, 2, 3, and negative 2, 4, negative 4, with the negative 2, 4, negative 4 being our terminal point. So remember, this is my initial, that's where I'm starting, and this is my ending point. So the first thing we want to do is write the vector equation of a line, and you're going to be doing this quite a bit this year. So let's learn how to do this. Do this quickly. The first thing we need is our direction vector. That's our slope. Remember, that's our slope of our vector, and that's easy. It's just the end minus the terminal. So if I think about that, that's just negative 2 minus 1, 4 minus 2, negative 4 minus 3. And that's going to give us negative 3, 2, negative 7. Therefore, my equation of my line, be careful, in 2 dimensions it was x, y. We can go x, yz this time equals, ready, our initial point, which was this 1, 2, 3. Now, even though it's a point, I'm writing it as a vector form, plus t. Remember, t is just like, it's kind of like our parametric. It's as time moves on, where the new point's going to be. And our direction vector. And there we have it. Next, I'm going to write this in parametric form. And again, that's super easy. Oh no, focus, focus. Next, we're going to write this in parametric form. And that was easy. X equals 1 plus, this becomes negative 3t. And if you want to do 1 minus 3t, that's cool too. Y equals 2 plus 2t. And z therefore would equal 3 minus 7t. 3 minus 7t. So there's our parametric forms of our line. But now we want to write this in rectangular form, or that symmetric form. Now remember, we're going to do the same way we did up here. So for the first one, for x's, I can solve for the x, I can solve for t. T is equal to x minus 1 divided by negative 3. To get y, t equals, if I subtract 2, y minus 2 divided by 2. And the same thing for z's. T equals z minus 3 over negative 7. But there we go. You probably wanted to see that. Now, one thing I want to point out right here, remember up here. Up here, I didn't need to solve for the t. I could just plug this equation in for this one and get my equation of my line in 3 dimensions. Here, it's a lot harder. I'd have to plug this t in for this one, solve, plugged it in for this one, and I'd have to keep solving it. So it's way more complicated to get the equation of our line in 3 dimensions from parametric. So what we do is we just keep it in a symmetric form. Well, all 3 of these have the same parameter in common, t. Well, what does that mean? They are all equal. So I can do that. I can set this x minus 1 over negative 3 equal to y minus 2 over 2 equal to z minus 3 over negative 7. And all 3 of them are equal to each other. And this is the equation of our line in 3D. Now, we didn't simplify it. We didn't solve it or anything like that. You can, if you want to, cross multiply here, then solve whatever that is. Cross multiply here, solve it, whatever that is. But it's okay to leave it like this. And this is the equation of our line in 3D in rectangular, or that symmetric form right there. I hope you enjoyed the lesson. I look forward to seeing you guys soon. Bye-bye.